All right. Welcome. My name is Stephen Ottens. It also says that here. And I have a split job at the moment. I work in geodan research in Amsterdam, which is really convenient for this conference because it's just a train ride away. But I also work what used to be called Innovation Labs at the World Bank. The Innovation Labs is in flux. I have no clue where I'm working at the moment, but it's still the World Bank. And I'm going to talk about a project I did, or I'm doing for the World Bank. It's rural accessibility mapping. And that's very much about how long does it take someone to get somewhere, which all the cool kids visualize like this. For those who don't know this map, it's made in 1914 by John Bartholomew or something. Yeah, and it shows the travel time from London to any place in the world which they defined as the British Empire, basically. And I got the whole gig on the World Bank because I was doing something similar, and I tweeted about it, and then someone tweeted about it, and then someone at the World Bank tweeted me, do you want to work for us? So do tweet a lot. So this was the one I made, and it took me quite some time to figure out how to do this, but rendering the actual map takes like 5 minutes on this laptop, which was fine. However, for the World Bank, we're not interested in one city, let alone London. We're not interested in 2 villages, but we were doing 220,000 villages, which we were interested in how long it takes them to get to important amenities like banks and hospitals and schools and county offices, which were not that many. There were only 85,000 of them, but still it takes about 5 minutes to do one isochrone map, which was the map I showed earlier. And if I would do that for all 85,000, it's about a year to calculate that, which is way too long for the project we're doing. But luckily, we're not that interested in 85,000 isochrone maps. We're just interested in the distribution of how long does it take for someone, for the entire population in a region to get to the hospital, in this case, hospital. And you can see that like in 20 minutes, about 50% of the population of this particular province can reach hospital. And we're doing this because we want to know the impact of road improvement. So if we improve a road, what gain does the population get? So for this particular scenario, it will be 60% of the population who can reach the hospital within 20 minutes. So that's what I mean with accessibility. I was already talking with people around here, and accessibility is one of those words with many, many meanings. And I'm just looking for how long does it take someone to get to the nearest hospital or whatever, and then for the entire region. And there are various ways to do that. The old school way was just doing linear distance. Like, well, it's 10 kilometers. The average speed is 3 kilometers an hour, so it's more than 3 hours. This obviously is flawed. It has some Dutch flat landscape in mind, where any distance is the same speed. So there's already a better way where you take like roads and you say, well, if you're within X kilometers from a major highway, you're in this kind of classification. And if you're near a smaller roads, you'll be less connected. But I also need some water. Nowadays, we have this awesome open data set, which is worldwide, which is important for the World Bank, hence the name World. And it is OpenStreetMap, obviously. It's this vast ecosystem. It's not just the data, it's all the software around it which helps. Because we just don't just have a road network. We have really, really fast routing engines. These are two of them I know best, but there are more out there. But they can do a route from A to B within 1 millisecond, which is cool because then you can really start calculating how long does it take from one place to the other via the road network. So we had a use case where we're going to build this application for, which is the Guizhou province in China. And I don't know how many of you ever looked to OpenStreetMap in China. I can tell you, it's kind of spotty. This is, well, it's a bit zoomed in. If you zoom out, you don't see anything. So this is like one of the roads which obviously is not correct. So we cheated a bit because we're not that interested in mapping China for various reasons. We wanted to develop this platform. So once again, there's this ecosphere of tools related to OSM, and one of them is OGR to OSM, which can take a shapefile. We bought a shapefile in the Chinese eBay with the road network, which has the best license ever. And I asked Ivan if he would be here, but unfortunately for him, he isn't. Otherwise, he would have a field day with Belgian beers, I guess. And so I put the shapefile into through OGR to OSM, and I get this OSM file with the road network. And so the blue line is the province we're working on, and there are about 200,000 roads in this road network. And based on this data, we started building the tool, which is really meant for local government to get a feeling of whether or not it makes sense to do the road improvement. So it's very easy. You have a map of the entire province, and we're mainly working with counties. So the county officer could click on its county, then the application will produce these kind of awesome graphs, which tells you the distribution. And this is all nice and interactive. So you could also say, I'm only interested in those villages which are more than an hour away from a hospital, and then you can see how that affects the other regions, the other amenities. So apparently there is no bank closer than half an hour if you're already an hour away from hospital. And you could download these files and do some more analysis. And that's, of course, where this whole thing started. It's kind of small, so. You could upload a new scenario, and then you could see the effect. So in this case, you would be a lot faster. More of the population will be within an hour at the hospital. So yeah, now the tricky bit. The live demo, because it's actually really fast. Let's see. So, oh, it says disconnected. Of course it does. That's always what happens. Hot Summit, no internet. Disconnect. Connect. Otherwise we'll connect it. Well, we'll see if it does it. It sees we have internet disconnected. Hang on, maybe we don't actually. Well, let's see what it does. So I could click where my So that one. No, it really says disconnected. If someone has a Wi-Fi hotspot which works, we could try it. Otherwise, I have it bit cached, so it might work in a bit. So anyway, so if you click on it, it will start the actual calculation. Oh, you don't see anything. Oh, that doesn't really help. Sorry about that. Why isn't anyone saying that you're not seeing anything? I told the computer to share the screens, but weirdness. So this is the proof of concept which I built. So you could choose whatever level you want. And since most of them want local, so you click on it and it will start. But as I said, for some reason the connection doesn't work. It will send your polygon to the server, and that will do the calculation, and then it will send the CSV back, and you get a nice list of all the different all the results which have been calculated so far, and you can compare them. And I selected compare, so you can for the Wangmo county. We have a baseline, which is the current situation, and then I uploaded a new scenario called All Stephen Fix. And as you can see, it actually fixes stuff. The accessibility for the entire region went up. It's also because I just set the max speed on all the roads a lot higher. But it will give you a summary because this kind of information is what the officials really just want. They want a nice set of statistics which they can copy paste. But it also gives you the nice interactive graphs which you can do. I'm only interested in the area which is close by. So all these graphs go with you, and then you have the whole table. So from each village we have a population, and then this is in minutes actually, and you can see that prefectures are really far away. There are not that many. There are 5 of them in the entire province, and you can it's all CSV, so you can also download this information and load it into, for instance, QGIS. I'm used to the state of the map FOSS4G conferences where everything goes really technical. So I also went a bit technical, which I hope people don't mind too much, because it's kind of neat how it all works. I'm using OSRM, the routing engine, and you can give it 2 sets of locations. In this case, it's villages and banks, and it will produce a table which says for village 1 to bank 1, it will take 5 minutes, etc., etc. Then you can get the fastest one. So you get for village 1, it will take 3 minutes to the bank, village 2, 1 minute. Because we don't really care about all the other banks, we're just interested in the fastest one. So you do that for banks, you do that for hospitals, and for whatever amenity you have. You combine all this data, so you get a nice big table with, for each amenity and each village, how long it takes. Well, obviously you want to have the location of the village and the population, so you combine those. And then you get your big CSV file, which you send over to the client. However, when I was working on this, I discovered that doing this for all the villages and all the amenities was a bit too much because it's 18.7 billion possible routes. Well, 18.7 billion routes it has to calculate, which is out of way more possible routes. And you run into memory issues and all kind of weirdness. So I talked with several way smarter people, and in the end we said we just cut our data set into smaller tiles. So this is like 4,000 villages or so, and we start calculating with those. And we're not interested in all the amenities. So if we're interested in banks, we're only interested in the nearest banks. And we can be pretty sure that any bank which is like an hour away or well 120 kilometers away from the edge is not the nearest bank on any given road network. So we can like filter out a bit so it's a bit more lean. You can, because they're all nice squares, you can all do parallel stuff, which scales very nicely, which is also very useful in this kind of stuff. And like I said, you get this CSV file which you can load natively in everyone's favorite desktop editor. It has a weird button with a comma. If you ever wondered what it does, it's a magical CSV importer. This is literally what happens if you import if you add, so you do browse, you say this is my file, it fills in everything you need. It's like, it knows which are the coordinates, it knows it's a CSV item. Yeah. So you do this, you get a nice point map of all the villages with all the attributes. And we're back to the nice isochrone maps. It has a contour function which you can use to create these beautiful visualizations. Oh, I'm almost done. So this is the baseline scenario, and you can then create the same map of an improved road. So you can see here, they propose to improve this road, so this whole area gets better connected. And well, the same here, there are some roads. This one's also a major one. If you improve that, the whole north corner of the county improves. But like I said, it's a proof of concept, and with proof of concepts you take shortcuts, and there's like all this hard-coded stuff in the software. So what we're now doing, now we're finished this proof of concept for Guizhou, and people said, well, it is actually useful. We're gonna make it, first of all, strip out all the hard-coded stuff, so you can load in any region. You can have like multiple regions to work with. Have a nice admin interface, so now you have to do all kind of in the code editing and stuff. We want to get rid of that. As you saw, there's this whole list of results. You want to filter those. And this one is the most fun, and this one is going to take the most work as well. So in the web client, you want to click on the road, and you want to say, well, this road we're going to improve. The speed will be 60 kilometers an hour from now on. Give me the results. Those are going to come. So I already did this bit where you can have like multiple regions. Yeah, and everything else is coming there. So if people like this, they're happy to clone and fork and create issues. And other than that, are there any questions? Yeah.
Have you compared it to other data sets to verify?
As in, you mean verify whether the data is correct or whether the...
Whether the bank is there? Is it closed?
No, we didn't. Because this one actually doesn't really care about the data. It's more the software to do it. I already figured that since it really relies on the quality of the OpenStreetMap data, you can use it to see where data is missing, because you will get like really disconnected areas. Then you can say, well, there's something, either it's a really disconnected area or we're missing roads, but no.
Have you thought about incorporating capacity as well? Like this hospital is reachable, but it has 5 beds for 50 million people, things like that. Is it?
It's vaguely on the radar, as in it's one of those nice to haves, but no, it's like low on the list, but it's definitely an interesting one, because then you can start matching and but then you're not just interested in the nearest hospital, you're also interested in big hospitals, or so it's a more complex problem. Yeah.
So that clearware file, if you don't have that, what do you do? Of the roads? Bought off the Chinese.
If you don't have a road network,
Yeah.
well then you first start mapping. It's that I'm Dutch, and we're used to having everything mapped. So I'm still having this philosophy where like we already have the data, we just need the tools. But being here, I realized that having the data is also very often a problem. But well.
And how did you know that file was accurate?
In this case, we know because the Chinese government was not really happy that we found it, which says quite a lot. But other than that, no, it's these kind of analyses are as good as the data, and you can use it to a certain extent to do analysis on your own data, and then to a certain extent you just have to trust your data. So it's better than what they were doing now. Like, well, we think it's good, and the internal audit organization said, well, that's not good enough for us. You have to have some way of measuring. And
like, because I'm trying to see how I could scale this to use it on the whole world, and in other parts where definitely, probably, I will not find it on eBay. So, if I would use as a model for the roads, like the OSM structure, and maybe do some, like maybe this is 50, if it's a truck, maybe it's 30, how it would be
if you're gonna do the whole world, I think this is too accurate.
No, just let's say that I want to do for Romania, for part of Romania, and I will download the PDF, I will extract the roads, and
you don't need to extract roads, you just need to download the PDF, because OSRM will do the whole extraction bit. So it's you need the PDF, and also the villages and the POIs, you can get them out of OpenStreetMap, but you have to do it yourself because you need to check them. I did not trust the OpenStreetMap tagging too much to do that directly from OpenStreetMap. Like, you get it, you check it, and then so that's a bit of data wrangling you have to do. But I think you could run it on Romania, especially if you're doing it on village and not on a house level, because the house level is just suddenly like 10 or 100,000 more. But
no, it will be only on a village level,
yeah.
Maybe the central is how it works.
Well, if you have the data, we can easily set it up and test it. Yeah.
So, do you have any case studies or testimonials from the model was part, how people have used this information?
So this one was in China, and we're going to do Tanzania with the Tanzania World Bank local offices. The China one, it was really an eye-opener for them. They had the website in front of them and QGIS with the road network, where they could say, well, I want to improve this road, and then upload the new road network, which is, let's see if I can show. It's the first step, which I did not show. There's the upload step. Oh yeah, we don't have internet. Well, there's an upload step where you upload your road network, which you can compare to the baseline. And, oh, it actually worked. So it's pretty simple. You have to have a zip file with a certain amount of files. So we explained them to explain that step, and then they could get all the results, and they were pretty excited about that.
The end users, like people who
No, the government. So it's the government officials who have to do the planning of the road improvement. The people in the villages, well, they probably will be happy once there will be a useful road, but they're not that much involved in this step of the process. Yeah.
Just one more question, did you ever think about using elevation data?
Yes, we did, and we've been discussing that. So OSRM did not have elevation data support when I started with it, but it does do now. But I haven't followed up on that. But yeah, it's an issue. I know.
Thank you for your help.
Welcome.